Hello everyone, I'm Manognya.
I'm Daksh.
We're excited to share our ES116 project, a simple wearable system that alerts you when you start to doze off while studying.
Our solution has a headphone cap with an MPU6050 sensor module which includes an accelerometer and a gyroscope.
But in our case, we specifically use the accelerometer data to detect whether your head tilt is too far away, forward, or backwards, a common sign that someone is dozing off.
The MPU6050 continuously sends acceleration data on Arduino board. From this data, we calculate the pitch angle of your head using trigonometric formulas. If the pitch is in the range of 0 to 10 degrees forward or 75 to 85 degrees backward, we assume the user might be dozing off.
At the top, we include necessary libraries for MPU 6050 sensor. There is Adafruit MPU6050 Adafruit sensor and wire.h. Plus, we include mat.app is for calculating angles using trigonometric functions. We initiate the MPU6050 using Adafruit MPU6050 MPU and define a buzzer pin 8 in this case. Inside the setup function, we begin serial communication for debugging. A message is printed for the serial monitor to indicate our angle detection, then we will start. Next, the code over here check if MPU6050 is properly connected. If not, it prints an error and halts the program. Once the sensor is found, we configure it to set accelerometer range to plus minus 80 and gyroscope range to plus minus 500 degrees per second and a filter bandwidth of 21 Hz for smoothing the data. We also set buzzer pin and as an output to ensure it's off at the start. Now let's move to the loop function. Here we read the sensor data including the acceleration on the x, y, and z axis and store it in variables ax, ay, az. Using these values, we calculate the pitch and roll using trigonometry. Pitch is calculated using x-axis and the magnitude of y and z, and roll is based on the y-axis and magnitude of x and z. Now here comes the interesting part. We check if the pitch is slightly negative between 0 to minus 8 degrees or, ste- or steeply tilted between 75 to 85 degrees. It is a common condition we uh, when we tilt our head while dozing off. This turns on the buzzer. And finally, a short delay of 500 milliseconds is given so that it has time to read the output.
In our project, we are using Arduino Uno along with a sensor shield. This shield has multiple built-in components like LED, buttons, sensors, and buzzer. But for this project, we are only using the buzzer from the shield. The Arduino Uno is the main controller. It takes input from the external motion sensor, the MP6050, and calculates the tilt angle on the device. Then the simple logic. Then using the simple logic, the Arduino checks whether tilt crosses a certain limit. If it does, it activates the buzzer on the shield to alert us. MPU6050 is a tiny but powerful motion tracking device. It combines 3-axis accelerometer and 3-axis gyroscope in one chip. The accelerometer measures linear acceleration, basically how fast something is speeding up or slowing down in a direction. The gyroscope, on the other hand, measures rotation or how fast something is turning. In our project, we are using accelerometer part to calculate two key angles, pitch and roll, which tells us how the device is tilted forward, backward, or sideways. We calculate these angles using the raw acceleration values of x, y, z. Then we check if the pitch angle crosses certain limits, like if the device tilts so too far. If that happens, we turn on a buzzer as an alert for someone who is sleeping.
Now let's see the buzzer in action. As soon as the head is tilted forward, the buzzer starts buzzing. The same happens if the head is tilted backwards. We tested this and it triggers whenever drowsiness like head tilts occurs. It's lightweight, wearable, and does not interrupt normal studying unless you start to doze off.
Through this project, we learned about sensor calibration, signal noise, angle calculation, and real-time processing on embedded systems. The biggest takeaway was converting a simple real-life problem into a working prototype.
This card could be useful not just for the students but also security guards, night shift workers, or anyone who needs to stay alert for long times.
It's a simple but effective solution that actually works, and we hope this idea can someday evolve into more advanced wearable.
What makes our project special is that how we have taken a very real, everyday problem, dozing off while studying, and created a wearable minimalistic solution. And does not rely on cameras or screens. It detects drowsiness based on only head tilt, which makes it ideal for low light environments. It's simple, scalable, and solves a real life problem.
Thanks for
Thanks for
watching.
watching.